Today we're going to be looking at 3 different examples that will help you with your assignment today in class. Let's get started with the first example. The first example, we're going to be finding zeros of a polynomial by factoring, and the first polynomial that we're going to look at is f of x equals x cubed minus 6x squared minus 16x. The first thing that you want to do with this polynomial is set it equal to 0 because we're trying to find the zeros. Once you've got it set equal to 0, I would look to factor out the greatest common factor if there is one. In this specific example, x is the greatest common factor, so I factored out an x out of each term, and we're left with x times x squared minus 6x minus 16. From here, we're going to factor the remaining polynomial x squared minus 6x minus 16. This polynomial is a quadratic. I factored it just by looking at a times c, which would be 1 times negative 16, and I thought of what two numbers are going to multiply to negative 16 but add up to the middle term, b, negative 6. Those two terms would be negative 8 and positive 2, so that's why x squared minus 6x minus 16 factors to x minus 8 and x plus 2. Once I've got it all factored, I'm going to set each factor equal to 0 and solve. So my final answer for the zeros of this polynomial are 0, 8, and negative 2. Let's look at the next example. Oh, we're all over the place. Sorry, guys. Alright, example 2. State the degree, list the zeros with their multiplicity, and indicate whether or not they cross the x-axis, and then sketch the graph of the polynomial. The polynomial we're going to look at is f of x equals x times x minus 2 squared times x plus 1 cubed. This polynomial is already in factored form, so it's really easy to find the zeros. I just set each of those factors equal to 0. The x equals 0 would be 1, 0. X minus 2, set it equal to 0, solve. 2 would be another 0. X plus 1, set it equal to 0, you get negative 1. So those are going to be our 3 zeros in this problem. Now, looking at the way that it's set up, it's in factored form. It's very easy to identify the multiplicity. X equals 0 is going to have a multiplicity of 1. X minus 2 squared is going to have a multiplicity of 2. It's easy to identify here because 2, it's all to the squared power, so it's going to really show up twice, x minus 2, x minus 2. And x plus 1 would have a multiplicity of 3 because it's x plus 1 to the power of 3. So each of those multiplicities, 1, 2, and 3, tells us something about what the graph is going to look like, and we're going to talk about that next. Like I said, multiplicity is the power of each factor. The degree of this polynomial would be 6 because it's the sum of the multiplicities. So if we look at this, stop there for a second, x equals 0 had a multiplicity of 1, x equals 2 had a multiplicity of 2, so far it's a degree 3, and then the last one, x equals negative 1, had a multiplicity of 3, so it would be a total degree of 6. Now let's talk about multiplicities a little bit more to refresh your memory about stuff that we did learn in Algebra 2. Multiplicities are going to vary depending on whether there's an odd or an even. Odd multiplicities cross the x-axis. The higher the odd power, the flatter the curve through the 0. So think cubics, x to the 5th, y equals x is just going to go straight through, just like a linear function. But once we start cubing it to the 5th, the 7th, it's going to curve through the 0. The higher the power, the flatter the curve through the 0. For even multiplicities, they're not going to cross the x-axis, they're going to reach the x-axis and bounce back. The higher the even power, the flatter the bounce back is going to be. So here's a couple pictures that you might want to get in your notes. It's very similar to some notes we took last week on what different curves look like, odd and even. But odd multiplicities would look similar to the three that I just drew. I tried to make it show that linear x in pink would just go straight through, x to the third in green kind of curves through, x to the fifth in red still curves through, but the curve should be a little flatter the closer that it gets to the actual zero. For even, just think of a quadratic, it's going to bounce back, and the higher the power, the flatter the curve, which I tried to demonstrate with x to the fourth in green and x to the sixth in red. So let's wrap up this problem by sketching a graph of the polynomial that we were given. So to sketch this, we're going to analyze a few things. We're going to analyze the degree, the leading coefficient, and the multiplicities of the zeros. Like I said earlier, this is a 6-degree polynomial. Now this is a positive leading coefficient, because if I look up at the x terms in the factored form, and I think if it had been expanded out or multiplied out, my highest power should be a positive coefficient. The x on the outside is positive, the x in the cube, x plus 1 cubed, x is positive, so it's going to still be positive. It wouldn't really matter if x minus 2 was negative, because if I multiplied it out or factored it out, even if it was a negative x inside of the x minus 2 squared, once I actually squared the function, it would end up being a positive. So really, the two that I wanted to focus on were the single x out front and the x plus 1 cubed. Both of those x's are positive, so I know that when I multiply it all out, my leading coefficient is going to be positive. I don't really care right now what number it would be. It would be 1 in this case, but I'm just trying to get a sketch of this. So the positive tells me the end behavior of this function. Even with a positive leading coefficient, I know both the ends as they go to positive infinity and negative infinity should be going up in both directions. So the first thing I'm going to do is plot my 3 zeros on my graph here. Once I've got them plotted, I'm going to think about the end behaviors. Again, it's even with a positive leading coefficient, so I know both the ends are going to go up. The first zero, if I start on the left, is x equals negative 1, which has a multiplicity of 3. So I tried to curve it through negative 1. My next zero, if I'm still going left to right, would be 0, which goes straight through, so I tried to go straight through, and my last zero would be x equals 2, which has a multiplicity of 2. So it's going to come back to that 0 and then bounce off. So this is an example of a sketch that I'd like you to do today. You don't have to be super accurate with your y values, but your zeros should be accurate, and your shapes of your zeros and your end behavior should be accurate on your sketches today. Let's see. Okay, last example for today is going to be write a cubic function for the given zeros in standard form. So here's our function, or here's our zeros. 2, negative 1, oh, I changed that 0. Let's get rid of that. I think I changed it. We'll try this one. The zeros are 2, negative 1, and 1. So we're working backwards now. We're given the zeros, we want to work back to the factors. So I set it up like this because I'm going to take the zeros and rewrite them into factors. And if I know the 0, it's like working backwards. So example, if one of the zeros was 3, the factor would be x minus 3. So once I've got it set up in factored form, all I have to do is expand it. Pick 2 of the factors to start with and multiply them out, and then multiply by the last one. Apparently I rewrote this a couple times. Okay, so right there, I'm going to keep playing it because I think I erased that, but right there is the first two, x minus 2 and x plus 1, multiplied out. So I multiplied it out, and then I combined like terms, and then I'm left with these two polynomials. I'm going to multiply them out again, and then I'm going to combine like terms and rewrite it into standard form. So I'll show you the steps here, multiply it out, combine like terms, and reorder in standard form. And that would be my final polynomial answer. Again, I hope that this helps with your homework assignment. You can also use the book for examples. Go ahead and use the rest of the class to get going on your assignment. Ask each other questions if you need help with factoring or anything like that, and good luck today.